number 2, A2. So we have a spring and it's extended by 8 millimeters and it's with a force, by a force of 1.5 newtons, and we want the K, the spring constant. So what formula do I use here? What's his name? Hooke's law, isn't it?
Yeah.
F equals K. Yeah. Now, provided that you know how to divide, which I'm sure you do, this question is quite easy. K is F over delta X. So, 1.5 divided by 8 times 10 power minus 3. There we go. And importantly here, what is the unit? Newtons per meter, isn't it? How many marks? 2 marks. Okay. Right, that's part A. Now part B. Can I scroll down? Yeah. So the spring is now, oh sorry, don't draw that, I drew that wrong, I think. Is it horizontal or vertical? The spring's then horizontal. Okay, I drew that backwards. So the spring is now attached to a horizontal, put on a horizontal surface.
Isn't that wrong?
Hang on. Just give me 5 seconds to read this to myself. The spring is then fastened at one end to a smooth horizontal surface and a mass is attached to the free end. The mass is pulled and released. Okay, I was right the first time. It's attached to this table. There's the spring. And there's a mass of 0.6 kilograms attached to the end. And then what happens is you come along and somebody then pulls it down. What distance? 4 millimeters.
It's supposed to be vertical instead of horizontal.
No, I think what's confusing here is they're saying it's attached to a horizontal table. So the table is horizontal. This is what confused me when you're reading it quickly. Don't do that in the exam. Okay. Right, so we're going ahead. Fine. What is the period of vibration of the mass? Okay. So they would like the T here. In fact, there is a formula in the formula book for this exact problem. I'll tell you where it is now if you want to have a look at it. Huh? If you want, you can go to page... Yeah. Page 6 is the formula book. And it says it right there. For a mass on a spring. It literally says that in the book. For a mass on a spring, the time is 2 pi root m over k. I mean, that formula for that problem. Huh? Yes. Yes. Now, do you know the m?
Yeah.
Do you know the k?
Yeah.
Do you know how to use your calculator? Mostly. So, you can get the answer here for me. 2 pi square root m. M is, sorry, what page am I at? 0.6 over k. What was k? 187.5.
0.35.
355 is the time. Seconds. K was from the previous part. Now the next one is a bit tricky. They can't all be easy. So that was part 1. Part 2. Yeah. Now you need to look back at the formula book as well. I don't even know if it's in the formula book. It is. It is not in the formula book. I'm afraid to tell you this, which is okay. It just means it's one that you need to learn. Well, actually, you could use this one in the formula book. They want the maximum velocity. No, you can't. All right. This is the formula I'd like to use here. What type of motion is this? Who knows what this is called when it's going up and down like this?
Simple harmonic.
Simple harmonic motion, isn't it? And you have a formula in simple harmonic motion for velocity.
Minus AW.
Yeah, A omega.
Omega
Square.
That's all.
No,
Minus
that's the formula for maximum velocity.
Yeah, it
You
was
want the
maximum.
Yeah. And you, okay, good, you remember that. Sorry, I was going to give you this one and then say when it's maximum that is 1. But good, you remember the formula for maximum.
it's omega theta.
A omega just.
No, sine of omega t, is that theta?
No, it was sorry, sine omega t.
Yeah, omega t on its own is a theta.
No, I'm not sure what you're asking me. It's sine omega t. They're multiplied in the sine.
I'm asking if they multiply together.
Yes, you're right. Okay, what's the A here? 4 millimeters. What's the omega? You don't know, but you can work it out quite easily by using this formula. T equals 2 pi over omega. So what does omega equal? 2 pi over t. So I can just put that back in there. Maximum velocity will be A multiplied 2 pi over t. 4 times 10 to the minus 3 times 2 times pi divided by time. And I got quite a small number here. 0.0707. 0.0708 meters per second, or if you prefer 7.08 centimeters a second. So, sorry, recap. This is in the formula book. So this one here you need to learn, not in the formula book, and then this one here is in the formula book. Yes, and then not in the formula book. So you need to know this one here for maximum velocity for simple harmonic motion.